Right, we're going to talk today, or I'm going to talk today about virtual machines and try and get you to realise what a boon that they are. A lot of people have never heard or never thought about VMs, and really it's a thing that you're missing a trick if you're not doing it. A virtual machine is a program, a piece of code that runs in your PC. Your PC, in this occasion, is called the host machine. And the program that you're running is called the virtual machine. But the virtual machine is itself another PC. It's got all the functionality of another computer. There's two versions of it. It can be what's called a bare metal VM or a fully hosted VM. Now, a bare metal VM runs on a server, and basically all you get on the server are the VMs. You don't have an underlying operating system. You've just got the virtual machine environment with so many virtual machines. So we'll not really be discussing that here. I'll allude to it when I explain one or two of the benefits. Or you get the fully hosted one, which is what I'm going to talk about, and it's what I use. And basically, my PC has got an icon on the desktop, and when I double click it, up pops my choice of virtual machines, and I open a virtual machine and I use it. The VM that I'm going to use can't have any more resources than the HM has. If I've got an 8 gigabyte machine, I can't have a 16 gigabyte virtual machine, because I can't obviously have more memory in the virtual machine than I can have in the real machine, or else they'd be using that all the time. And the other thing is, I need to have my own machine's memory as well. So in reality, if I've got an 8 gig machine, then I probably wouldn't be able to run a VM of more than about 4 gig. The processor and the BIOS for your machine both need to support virtualization, and they both need to have virtualization enabled. Now, if the processor you're using is less than about 15 years old, then it supports virtualization. Your BIOS might not have it switched on. I can't really go into how to do that because there are so many BIOSes. But if you know how to get to the BIOS, when your machine's starting up, you press F12 or F1 or escape or something to get into the BIOS. And if you have a wee look through there, you'll find there's a switch that enables virtualization. You don't need to do that. Nearly all machines have got it turned on by default. In fact, practically everything that I'm talking about today is enabled by default, is license-free, putting your hand in your pocket free, is doing any work free. It really is all there already. People just don't know about it. So what do we use a virtual machine for? We can try out a new operating system. You've heard people talking about Linux or using a Macintosh, and you don't know if you'd like to try that or not. And you certainly don't want to go and buy a Mac in order to get trying out Catalina, because that's serious money. Or Windows 11. Windows 11 came along, and for the first 6 months of the year, I used Windows 11 purely on virtual machines. If I've got an existing operating system, I want to try a different version of it. Can I try the 32-bit version of this? Can I try the 64-bit? I can do that in a VM. I'd like to experiment, will this program run with less memory? Will it run with more memory? How much disk does it need? How much CPU does it need in order to operate? What speed a CPU? And I can tweak all of those things in hardware without having to go and buy or build a machine to do those kind of tests. Now, optimizing hardware utilization, as you know, I used to work in the college and we had a server room with servers in it. Now, one of these servers was the web server for the admission system. And the admission system was really, really busy in July and August. When the results are coming out, people are getting onto courses, it's all getting set up. July, August, admission system was heaving. But at that time, there's nobody really in the college. And so the login server was doing nothing. The rest of the year, the login server's busy. When all the students are in the college, the login server's busy, busy, busy. Everybody's using it all day, all the time. But there's no admissions work happening, so the admissions server is practically quiet. So what we did is we put two virtual machines on the same server, and for 10 months of the year, the login servers get 80% of the resources, the admission server has 20% of the resources, and for the 2 months of the summer, the admission server gets 80% of the resources, and the login server gets 20% of the resources, and that's just a tweak. And because we could do that, it saved us £5,000 for a server and £5,000 a year for electricity and support and maintenance and running a technician to run that server, because we could use one server instead of two. And you can do lots and lots of tricks like that in the server room, whereby you make your servers bend bigger and smaller to suit the job in question. You ever had the situation where you get a document sent to you, and if you open it in your version of Office, when you send it back, it'll no longer open in their version of Office, or vice versa? If you get into that situation with somebody, you can put in a version of the operating system and a version of the Office that they're using on a VM, and you can open the document in the VM and know that if you save it and send it back, it's in exactly the same position as they are, and that stops all of that good stuff happening. Now, I've done a dozen chats on here about different things, and you've seen me using a virtual machine. I use that nice blue version of Windows 10, and I use that because it's clean. My own machine's incredibly cluttered. It's got dozens of program environments for different microchips. It's got design documents, it's got Office, it's got the whole, but you don't need that if you're demonstrating something. What you want is just the clean machine. And that's what I tend to do, is bring up the clean machine for demonstrating to you guys on a Sunday. I had a phone call out the blue a couple of years ago from a company that needed a printed circuit board that I designed 30 years ago. And I designed it and it went to manufacturing, and away it went. I forgot all about it. And these guys could no longer contact the company. The company that had made the thing were now defunct. But by tracing the copyright stuff on the old PCB, they found out the name of my little company. They contacted Companies House, got my number and phoned me. We desperately need one of these printed circuit boards. But I did it in DOS 30 years ago. So in order to get them a new printed circuit board, I spun up a VM, opened DOS on it. I still had the files, so I could then make the gerbers, send it to our friends in China, and get a dozen PCBs for about a tenner. Oh, I was flavour of the month with those guys that week. Don't know if I was when the bill came in from me, but hey, we'll worry about that some other time. Or if you're working in amateur radio, lots and lots of amateur radio equipment, receivers, transmitters, transceivers, decoders, encoders, RTTY kit, all of that stuff uses software that was handwritten for it at the time by the person that designed the hardware. And a lot of that, you've got the hardware now, but the software for it was written for Windows XP, or written for Windows 7, or written for DOS even, and you don't have this, you can't get that to run in a modern machine. Again, you spin up a VM, you plug in the hardware, and you can use the hardware with the software that was written for it 30 years ago, 20 years ago, by whoever it was that designed it. Great for that. You're writing programs and you want to see if your program will work on Windows, Linux, Windows 7, Windows 10, Windows 11, Macintosh, and you want to try them all, then rather than having to have a machine for each of those, you simply have a VM, a virtual machine with each of those. Demonstrations, already mentioned. Using multiple simultaneous PCs, if I want to have half a dozen machines attack a server to find out if the server can handle it, then rather than buy, build, or steal or borrow half a dozen PCs, I just put up half a dozen virtual PCs, and they all go onto the network at the same time, and they all send and receive messages, and I can make things as busy or as quiet on the network as I want without having to invest in a lot of hardware that I hardly ever use. Virtual appliances. I'm going to give you an example of a virtual appliance, but a virtual appliance goes like this. Imagine that I've got a magic example of JMRI working. It's on Linux. And on Linux, I've got JMRI working. It's version 9.7 of Java that you need for it. And then JMRI on top of that. And then you need JMRI configured in a certain way because it's using the Wi-Fi throttles and it's using that to control EasyBus via a little DLL that I've written, a little runtime library. That's complicated. If you need to set that up or you want to run that because you've got the same setup, then you would have to learn how to install Linux, how to configure Linux, how to do the settings for this on Linux. Same with Java, how to get the right version of Java, how to install it, how to configure it. Then JMRI, how to install it, how to configure it, how to set it up to suit with it. And the same with the virtual throttles and all of that stuff. And that's going to be an instruction book that's 30 pages long and has a million places to go wrong in it when you start trying to do it yourself remotely. So what I do is I get mine working, I save it as a virtual machine and send the file to you. You open it up, you open the virtual machine and it's there. The Linux, the JMRI, the Java, the virtual throttles, the EasyBus controller, they're all installed, they're all setting, they're all working. All you have to do is plug in the hardware and you're off to the races. Virtual appliances are really, really clever and really, really useful. Now, obviously, if you're doing anything with viruses or malware, now, I'm not going to say that I write viruses or have anything to do with malware because I'm a good boy and I wouldn't do anything like that. But if I was out on the web and I find a really dodgy Russian or Czechoslovakian site or something that's got a really expensive piece of software for free download, and that piece of software usually costs £2,000, but here they're offering it for free, it's likely to be riddled with horrible things. So what I'll do is I'll open up a VM and download it in there and have a play with it and see if it's useful to me and if I can get it to work and all that good stuff. Knowing if it starts to infect the machine, then the machine's not the machine I'm sitting at, it's a virtual machine. And at the end of the session, I just switch the VM off and it's away. So all the viruses and all that stuff haven't been on the machine. There's no way that they're going to catch anything. There's no way they're going to spread. Great for that. You've got a machine in the house, sitting in your front room. You use it. It's got your banking details on it. It's got credit card details. It's got logins for all your porn sites. I mean, for all your important sites. It's got all that good stuff on it. But they've got the Granwains coming over. And if the Granwains go onto your computer, they're liable to start installing Minecraft or whatever the game of the month is, or downloading that program that I was just telling you about for Czechoslovakia. And that could cause all sorts of grief. So what you do is you either put your personal stuff in a VM, so that only if you've opened the VM and opened the VM and get in through the passwords in the VM, do you get to your personal banking and passworded stuff and all that. Or you put the Granwains on a VM, so they've got an empty machine and they can do what they like with it, knowing that they can't do any damage to the PC that you're sitting in front of. In the same way, some people have VMs for engineering type programs versus VMs for design stuff, so that when they're working in design, they're not getting constantly interrupted by emails arriving and social media and all that stuff, and keeping components of your life separate by having them in separate virtual machines all in the one desktop and only having one open at a time. Couple of more and I'm done here. If I am going to start and set something up, remember that complicated JMRI setup? It's very easy to get lost halfway through that. So what I do is I do it on a VM and I go 3/4 of the way through and I say, no, I've made a total hash of that. I'll put that to one side. I open another VM and I try it a different way and see if that's better or worse than the first one. And it turns out it's even worse. So I scrap that and open a third and try it a different way until I get to the way that works. And I can then scrap the rest of the VMs and I know how to do this. Whereas if I try to do it on my own machine, I get it wrong the first time. If I then try to roll it back and uninstall this and uninstall that and take that back to that version, then I end up with things that are no longer working, things that are at the wrong version, configuration files, directories that are left there with documents in them that shouldn't be there. Whereas if I start with completely different, completely empty, parallel VMs, then I know that I'm only working on the one problem at a time and I'm not having to continually backtrack. And in exactly the same way, back to JMRI, JMRI runs on top of Java. That's what the J is in JMRI. MPLAB-X, which is what you use for programming PICs, runs on top of NetBeans, and NetBeans runs on top of Java. And there's half a dozen other programs, all the Eclipses, Eclipse IDE that gets used for umpteen different design things, all run on top of Java. They all install their own version of Java, just as a matter of interest in the way in. And if you install a new version of Java, that could break a previous version of Java. So I've installed JMRI and now my MPLAB doesn't work. So install MPLAB again and now my JMRI doesn't work. And it's the same with Python. Inkscape, FreeCAD, OpenSCAD, there's about 30 different products that all use Python. And they all use different versions of Python. And if you put one version of Python on, it's liable to overwrite the settings for another version of Python. And so, because you've installed a new program, certain old programs won't work. If you use virtual machines, all that stuff goes away. So there's a dozen, there's more than a dozen. It only took me about 10 minutes to list these ways that I personally use virtual machines. And like I say, there's a use there for everybody. So what do we need? We need a CPU. The CPU has to be virtualization capable. You need memory, and preferably a lot of it. You need a disk, either a hard disk or an SSD. Now what happens is that if I install Windows, Windows takes up about 1 gigabyte of my hard disk. So when I'm installing a Windows virtual machine, it'll take up about 1 gig of my hard disk. And as I install more software into that virtual machine, the virtual machine's files will get bigger and bigger and bigger and bigger. So I have to have quite a bit of disk space available if I'm going to use a virtual machine a lot. The other thing is when I'm setting it up, I can tell it, oh, you've got a 20 gig hard drive, which means never go above 20 gig. When it gets to 20 gig, start giving me the you are running out of hard disk space warnings. You know, which is a thing that's sometimes useful. Also, I would prefer using an SSD, a solid state disk, to an old-fashioned spinning RUSC disk. A spinning RUSC disk is fast enough, but SSDs are faster. Software, you need to have virtualization software, obviously, to use it. Turns out you've already got a lot of it, and the stuff that you don't have, you can get for nothing. You also need a license. For the most part, you've already got the license. If you need a license, then for non-commercial use, usually the license costs nothing. The only thing they insist is that you give them your email address so they can send you the latest updates once a month or whatever, but it's not a big deal. So let me give you some examples here about how much processor you need. That is the machine that I am sitting at. I took that off this machine last week. You notice the highlighted bit in the center there. It says 4 cores, 4 logical processors, and virtualization is enabled. Right? Now this machine has got 24 gig of memory. It's got a lot of memory in it, and I'm using about 8 gig at the minute. If I put my mouse in the middle of that, this is, of course, the task manager. To get to the task manager, you put your mouse in the taskbar and right mouse task manager, and up this pops. The second tab along is the Performance tab. And once you're in the Performance tab, you can click in the CPU window, the memory window, the disk window, and all that good stuff all the way down. In the CPU window, it tells me how many cores, how many logical processors, and that I've got virtualization and it's enabled. If I put my mouse right in the center of that graph there and right mouse it, it tells me that I can change the graph too. Now the graph is currently overall utilization, overall use. So that graph shows me how busy the processor is. If I change it down to logical processors, then I get this. Remember the 4 cores? Well, there they are, and I can see that the 4 cores are all doing very similar things. And I can see how little use of the PC is being made and stuff like that. If I take that machine and start up a virtual machine on it, there we go. If you look up at the top, you see that I'm in a window. And I'm using Windows 11 x64 in the VMware workstation. So this is just a window on my machine that is currently running Windows 11. And I've highlighted the same thing, 2 virtual processors. I gave this machine to the 4 processors on my box. So the actual main computer is now running two of those cores, and the virtual machine is also running in 2 cores. And the thing that said virtualization has disappeared, and it now says virtual machine yes. Because you can't run a virtual machine inside a virtual machine. The virtualization software knows that it's already in a virtualization, and so it won't let you virtualize it any further. Now, this machine that I'm sitting in front of, that I'm running all this good stuff on, is not a high-spec box. There it's there. You can currently buy it on eBay for 50 quid. It's just a corporate desktop. It's the sort of thing that sits in front of secretaries and salesmen and stuff all over the corporate world. You can buy one for 50 quid. I've spent about £100 putting extra memory and an SSD into mine to make it a little bit quicker, but it doesn't have to be. And also, if you're interested, that Lenovo M93, there's a version of that now that comes out, and it's 6 inches square by 1 inch high. And that'll do this just as well as that. I know that because I've actually got one of the little 6-inch ones. And it's a brilliant little PC for 50 quid, 100 quid tops. So you don't need some big supercomputer. You don't need the latest gaming rig. You don't need dozens of cores and dozens of processors to use virtualization. The graphs on the left are the same machine. And on the left, it's running on its own, like it was a minute ago before I opened Windows 11. On the left, you see it's just ticking away there at 20% of utilization, 20% of use. And then on the right, that's me opened Windows 11 on it. So I've now got Windows 10 and Windows 11. If you look closely at the memory graph on the right-hand side, you can see the memory taking a step up as Windows 11 kicks in. And at that point, I'm running 2 machines. I'm running Windows 10 and Windows 11. And the Wi-Fi is up because Windows 11 is still finding itself. And that's why there's that lot of activity, because this Windows 11 machine's only been up for a few minutes, for a few seconds, in fact. Those graphs are, I think, 1 minute across. So the Windows 11 machine's been up for 30 seconds. So it's still phoning home, which is why the CPU is so busy. So let's actually get into the mechanics of doing this, the who's and wheres. There's half a dozen different virtualizations. Microsoft Hyper-V, you already own. If you're using Windows at the minute, you have Hyper-V. It's built into your machine. You just haven't switched it on. I'll show you how to do that. There's also a thing called Microsoft Sandbox, or actually it's Windows Sandbox. I've mistyped that. It's Windows Sandbox, it's called. And that's also in your PC at the minute. And also you haven't switched it on. So that's down to you if you want to do that. I'll talk to you about it in a minute. VMware, that's the one that I use. I use it a lot and it's wonderful. And you don't even need to install VMware to use it. You just need to install the VMware player to use it. I'll explain that as we go on. Oracle are a major player. They own the Oracle databases, they own Java, they own MySQL and all these other things. Big corporate beast, and they have got their own version of VMware, their own virtualization software. I've got that on this machine, but only because I need it for a virtual appliance. And I'll show you the virtual appliance as we go ahead on. You may have heard of Docker and or Kubernetes, which is one of the current buzzwords. And what that is effectively is the application that I'm using plus enough of the operating system to make that application work as a little tight virtual machine underneath the application. So if I've got JMRI on Java, then the window opens up with JMRI in it, but it's running on Java, but I can't get to the Java. The JMRI can use Linux's services. So the Docker has got Linux on it, plus JMRI on top of it. JMRI can use the Linux, but I can't even see the Linux. I can't get to the desktop and change the colors or any of that good stuff. It's simply enough to keep the application alive, which means I can have dozens of them. Dockers, I can have 30 Dockers open at the same time because they're all only using a tiny subset. But it's not for what we're doing here. Citrix is used by local authorities, police, fire brigades, people like that, where you have a central authority, and the central authority has big databases that everybody has to have access to, and they all have to have access to the same data at the same time, but they're all spread out geographically. So what you do is you give them all a remote Windows PC, and the Windows PC has got nothing on it except for this Citrix client. So they open up the Windows PC automatically opens up the Citrix client, and the Citrix client is logged into a virtual machine on the server back at Central. So that if somebody pays their poll tax in one office, everybody throughout the organisation knows that it's paid because it was all paid on the one rack of servers back in Air Central or wherever it happens to be. So it's not for what we are doing here. It's not really of interest. DOSBox is cheap and cheerful. It's a tiny little program. It's 74K, I think, tiny. You put it on your desktop. When you double click it, a DOS window opens. And that DOS window, you can play Doom in, or Castle Wolfenstein, or Lemmings, or any of these things that you might want to do on a DOS machine. But it's only for DOS, doesn't do anything else but DOS, but it does DOS very, very well. The big problem people have is a modern machine running DOS goes like the clappers, and so they have to have all sorts of ways of slowing it down, the old-fashioned DOS speeds. So I'm going to go through one of these, and I'm going to have a wee divert. Before I get too much older, I'm going to have a wee rant. It used to be in Windows 7, there was a thing called Virtual PC. And if you had a Windows 7 machine, you could download Virtual PC and install it, particularly if you wanted to use old Windows XP stuff on your new, shiny Windows 7 machine. And then it became a full VM system. Microsoft expanded it to the full animal, and it became known as Hypervisor through Windows 8. It's now called Hyper-V. And Hyper-V is installed as part of Windows 10 or Windows 11. So if you go to your start menu and search for turn Windows features on or off, as you can see, I've just started typing turn window into the search box there, and up has come the list. Right now, at this point, I'm going to depart for a minute because I've been asked this about 30 times. And I keep having to go through this wee chat. So if I do it to you guys, that's 28 times I don't have to do it again. If I'm searching for something in Windows, there are two possible searches. Down there, on the search bar near the button, it says type here to search. That will search the internet. That'll go to Bing, and Bing will search the internet and bring you back results in a Microsoft Edge browser page. Whereas the one at the top, which is inside the start menu, will search my machine for whatever it is I'm looking for. Now, I don't need the Bing thing to search the internet. If I want to search the internet, I'll open a browser that I know and trust, and I'll use the browser that I know and trust. I don't want to give Bing and I don't want to give Edge the traffic. So what I do is I go down to the taskbar, I right mouse, I go up to where it says search, I click on that, and I tick the word hidden. And from that point on, that search, click here to search thing no longer appears on my taskbar, which means there's more room on the taskbar for the things I want to be on the taskbar, and I'm not going to put something in there. And if I'm talking to somebody and they try to do that, they're not going to put it in there because there's no search bar there. And if I search for something, it's searching my machine, not the internet. If I want to go and look on the internet, I'll go onto the internet and look on the internet. Rant over. Back to installing Hypervisor. Turn Windows features on or off. And if you click on Turn Windows Features on or off, this appears. And right in the middle there, you'll see Hyper-V, which is Hypervisor. So I click on that, and it'll install the stuff and go fetch the files and all that stuff. Doesn't need to go to the internet to do this. It can do it online. It's already got the stuff when it installed Windows. It'll ask you to restart the machine. And once you restart the machine, you'll find if you start typing Hyper, that you've got Hyper-V Manager and Hyper-V Quick Create. And if you go to Hyper-V Manager, then there you are. There's a Hyper-V Manager that's got a dozen virtual machines in it. And for each of these virtual machines, there's all the settings and what you can and can't do. So already there, it's dead simple. It runs on the Windows model. Windows Sandbox is fascinating. It uses the same Hypervisor program, but what it does is it takes your existing PC as the virtual machine. So it takes your PC. You can't run Linux on this. You can't run a Macintosh on this. It only runs the version of Windows that you currently have installed with all the programs that you currently have installed. So it takes a snapshot of your machine and brings that up as a virtual machine. So you can say, what would happen if I installed that on top of that, and I installed that, and I deleted that, and I tried that, and suddenly, oh, I can no longer use MPLAB, or I can no longer get JAL to work, or whatever it is. Okay, delete that. Go back to where I was and take it from there again. It literally lets you go in and play with your machine without altering your machine. Lets you go in and, I want to go in and mess about with the registry, but I'm scared that if I mess about with the registry, the machine might never start again. So what I do is I bring up the sandbox, go and mess about with the registry, see if it works. And if the machine will never start again, that's okay. I just shut the sandbox and then open the sandbox again and start from scratch. Sandbox is a useful little thing, and it's already built in there. And as I put in there, it's very useful if you've got a sus application, a dodgy website, or if you're doing something that's a bit naff, a bit dodgy, liable to lead you into grief. Virtual appliances. Oracle have a VM product called VirtualBox. And I've got a copy of it on this machine, and it's only there for one program. There's a type of chip called a Field Programmable Gate Array, FPGA. It's a chip with about 160 legs on it, one of these big boys. And what it does is an EEPROM on the board alongside it, and the EEPROM contains information. The FPGA has got thousands and thousands, millions of logic gates, but they're not connected to each other. They're not connected to anything. And when you switch it on, it reads the EEPROM, and the EEPROM connects all the logic gates in whatever pattern you want to be whatever you need this product to be. So the same FPGA can be a processor, it can be a video decoder, it can be a sound generator, it can be a signal generator. Remember the signal generator I fixed one of these Sundays a couple of months ago with the disappearing video? That's an FPGA. An FPGA can do almost anything. Now, one of the big companies that make FPGAs is called Xilinx. And every 3 or 4 years, they bring out a new generation of FPGAs. And as they bring out newer and newer FPGAs, they bring out newer and newer packages to support it. And they decided that the package called ISE that they used for their Spartan 6 and Spartan 3 FPGAs wasn't going to go to Windows 10 or Windows 11. So it stopped at Windows 7. So what they did was, rather than try to have, put engineers on this to get this software up to, it's incredibly complicated. So instead of giving people the job of making that work with Windows 10 and then Windows 11 when it came out and whatever's going to be out next year, they said, right, what we'll do is we'll use a Linux virtual machine and we'll make one of these virtual appliances. So you download Oracle VirtualBox, and then you download the virtual machine from Xilinx. When you open the virtual machine, there it's there. It's got all this interesting stuff about this virtual machine and how it works. And if you double click on the virtual machine, it actually opens a version of Linux with the program running. This stuff is incredibly complicated. It's a tool chain with about 20 or 30 different tools in it. There's floor plan managers and constraints managers and mappers and compilers and cross compilers. There's all sorts of stuff going on here. Setting it up would be a nightmare, whereas just downloading it from them and running it is dead straightforward. If you notice, I actually took this picture on Saturday, August the 5th of this year. But that project was last updated on the 21st of September 2018, 5 years ago. So really useful for going back in time, back to use that stuff. If I get an inquiry about an FPGA project, I don't have to worry about, oh no, do I have to go and install all that stuff? Because if you're downloading one of these environments, you're looking at 10, 20 gigabytes. They're enormous. And then days and days and days of setting it up. It's horrible. But with a virtual environment, a virtual appliance, you just open it and you go. We used them in the college with a virtual appliance that we couldn't even start. It was simply, you plugged it in and up it came and it did all your email filtering. And we'd no idea if it was Linux or Unix or what it was inside. We just plugged it in, plugged a network cable into it, and all the network get filtered. It had a web page that you could go to configure it on to give it the name and who your web people were, but you never got to see inside it. And actually the box came with a virtual appliance on it. That was an actual appliance. Right, VMware Workstation. If you go to VMware Workstation, well, first of all, it'll want to know your email address, and you'll have to tick an agreement to say you're going to accept updates from them. You can then either download and install Workstation itself. If you do download and install Workstation, never open it. Workstation itself, when you open it, you've got, I think it's 60 days grace to use it. And at that point, it starts nagging you every time you open your machine or open it. But Workstation Player works forever. And Workstation Player does everything that Workstation does, except you can't put up 6 machines and have them all speaking to each other on an internal network that's separate from your own network. You can have 6 machines all on your own network, all speaking to each other, but you can't have a little internal network inside your machine. And that's about the only benefit I can see from Workstation Player. So it's really not worth the hassle. So you get Workstation Player and not Workstation. There's what it looks like. That's mine. As you can see, I've got a Linux, I've got a Windows 10, I've got a Windows 11, both 64-bit. I've got 64-bit Windows 7, I've got a Raspberry Pi, I've got XP, and I've got a Mac all running there. And I can select any one of those, click on it, and I get that machine, and I can use it. In order to make a virtual machine, I open that window that you just saw, I tell it I want new, I fill in the details of the machine, I tell it where to save the files, I tell it where to get the software, and then I install it as if I was installing a brand new box in front of me. So let's walk through that. I'm going to make a Windows 7 32-bit machine, right? Because I don't have a Windows 7 32-bit machine and I need one for some project I'm on. So what I do is, if you follow the little star there, create new virtual machine. I tick on that. Welcome to the new virtual machine wizard. Am I going to install from my drive, my optical drive? Am I going to install from an ISO file? Or am I going to install nothing? There's an option. I can actually just tell it to make this machine and don't put anything on it. And every time I open it, it'll be like I switched on a machine that doesn't have an operating system until I put a disk in the drive, and then it'll install it. I can do that as well. But for this case, I'm going to install from an ISO. Okay, I've opened your ISO. I've noticed it's Windows 7. Have you got a product key? That's an old product key that I happen to have. I'm going to make it be used by somebody called Chick, and I'm not putting passwords on it. There's nothing to run down 2 stairs at a time for there. What am I going to call it? I'm going to call it Windows 7 32-bit, and I'm going to make it be in my machine. There's a D drive, and in the documents directory, there's another directory called virtual machines. So I'm going to put it in my virtual machines directory. How much hard disk? It recommends 60 gigabytes. I'm going to give it 80. Remember, it doesn't immediately take up 80 gigabytes. It'll take up about 1 gigabyte initially. But as I start adding programs and start using the disk, then that file will start to get bigger. And I'm going to use multiple files instead of just one file. That way I can get quicker access, and it makes it easier to move it. If I want to copy it from this machine to another machine, onto my laptop or onto the server at home here, I can do that. And it's ready to go. At this point, if I press finish, it goes. However, reading that summary, it's got 80 gigabytes split hard disk. It's only got 1024 megabytes, a 1 gig of memory. Don't much fancy that. So what I'm going to do is press the customize hardware button. Customize hardware, and there's a slider for how much memory. Now, a 32-bit processor on Windows will only take 4 gigabytes. So it's not worth going above 4 gigabytes. But 1 gigabyte's a bit puny, so I'm going to slide it up to 4 gigabytes. I can change the sound card, I can change the USB devices, I can change anything there. But all I'm going to do is change the memory, close that, and it's now creating a disk. And if you've ever installed Windows, you'll recognise this. Just installing files, installing Windows. This is all happening on a window inside my machine. If I zoom back a little bit, you can see that there's my Windows 10 machine. And in a window on the desktop, Windows 7 is installing. And not many minutes later, I've got a Windows 7 machine, a Windows 7 32-bit machine that I could now use for demonstration purposes. I could now check if JMRI would install on it. I can now check this. I can do whatever I want with that. And if I go to the About system, you'll see it's got 4 gigabytes, it's got a 32-bit operating system, it's got a product key, it's fully installed, and we're ready to go. If I shut that window and come back out, then I've got, again, if you follow the little asterisks, I've now got a Windows 7 32-bit virtual machine on my desktop that I can use just the same as all the other Debians and Windows and Macs and Raspberry Pis that I might want to use on the desktop. I can share network connections. All my network connections are shared. That machine's on the internet, unless I specifically go and stop it being on the internet. I can share drives, so I can make F drive on that new machine be the same as F drive on another machine. Either this machine that it's on, or another machine somewhere else in the house. The clipboard is shared. So if I'm in a document on my main machine, I can take a chunk of text, say a JAL program, and do Control-C to copy it. I can go back into the virtual machine and Control-V and paste it in there. Or if I get a result in the virtual machine, I can Control-Copy there and Control-Paste back to the machine on my desktop. If I put the mouse over the virtual machine and click on it, then I'm in the virtual machine. The mouse and keyboard are now sending information to the virtual machine. If I want out of the virtual machine, I do Control and Alt without the delete. Just Control and Alt, and it pops me out the virtual machine, and the mouse comes back to the main machine, and I can start typing back at the keyboard on the main machine, on the actual host machine as well. It's very, very simple. It's so simple that I've kind of over-egged it to go a wee bit on to let you guys see what I'm doing. But that's it. At this point, you can either give me some questions, give me comments, or show your appreciation by a minute of stunned silence.